So we have to prepare for another quiz. We're going to have quite a lot of quizzes. From now on, almost every session there will be a quiz. And this is going to be on the ratio test, something that we covered last week. And okay, so I'm only going to ask you a problem that involves the ratio test, but at some point I'm going to do also more general. I'm going to ask you to show that something is convergent and then figure out which test to use. That's not yet, so for now the question will be on a ratio test. So, and here are two examples of problems that you can expect. Here is one, let me write this one up here. N squared over 2 to the n, 1 from 0 to infinity. And, but I told you, it's going to be the ratio test, but I want to already say why is it ratio test? And how can you recognize? So I'm already anticipating this problem that we were going to deal with next time. You see at the top here, this is a polynomial, so it looks like a p-series. At the bottom, however, it looks like a geometric series, right? So when you have this mixture of two different types of series, that's one of the instances where you have to say ratio test. That's one of the reasons to go for the ratio test. Okay, so I'm going to do the ratio test, and for that it's really calculating a limit. So this problem is reduced to calculate a limit, but of course you have to make sure that you write it correctly. And what you do is you take the formula, put it in the denominator, right? Remember, it's this expression that we want to write here in absolute values. Okay, so what is this now? How do you get the top one? Well, replace every n by n plus 1. So let me show you how this works, right? So I have 2n. So I'm going to now replace the n's, these two n's here, with n plus 1. And perhaps even better, n plus 1 in parentheses. Here the parentheses are not needed, but if you are a little bit uncertain when parentheses were not, write them. It's never wrong. That's a good thing. It's never wrong. Can you believe that? Never wrong. How would you not want to do that? Okay. So, okay. Then what we do is rewrite this, simplify this fraction. The absolute values are no longer necessary because everything is positive. So what do we get? In the bottom, in top, what we have? We have the n plus 1 squared. And this one also will go in the top, 2 to the n. And then in the bottom, we have the 2n plus 1 and the n squared. And as always, we group them in together, right? What I mean with that is on top or bottom are the same expressions, except one has an n and the other one has an n plus 1, depending on where they were. Okay, so that allows us to simplify things. And there are three types of simplifications. Factorials is I will show it the next time, but with powers here, exponentials here, that is always you look at where's the biggest one, and that's in the bottom, and so now you subtract the smaller one from, and you have a 2 left. Okay, it's subtracting exponents, 2 to the power 1, but of course it's just 2. Now, what do you do with these kind of polynomial things, rational things? Well, that's the limit you have to calculate. So how do you do that? Well, as usual, the 2 here we can take out already, right? Let's not be distracted by it. Now, there are 2 things you can do here in the n plus 1 squared over n squared. I can combine them in the square, which I'm going to do because that's the easiest, and then take the limit of the inside part, which is very simple, because that one we will do by varying every single guy by n, namely the highest degree of top and bottom. Okay, so that will be here a half limit n going to infinity 1 plus 1 over n over 1, okay, perhaps not even write that, squared. And well, perhaps better, the square is now really outside the limit. We're taking the limit inside, and then inside we have that 1 over infinity is 0, so this goes to 0, and we have only 1 left, and then we square it, which is also 1, and we left finally with a half. Now what do we do with that? Well, it's the ratio test. And the ratio test, so what we're calculating is this row here. Well, no, let me not write that. That's not necessary. So, and what we need is that this is less than 1. This means convergent. Okay? All right. That's one type, and here's another type that involves factorials. I'll make a little bit, it's a little bit harder, this one, but okay. Squared 3 to the power n over 2n factorial, and this is for n going from 0 to infinity again. So we discussed when do ratio test. Again, this is going to be a ratio test, but why? Factorials. The answer is very easy. The moment you see factorials, it's really only thing you can do basically is the ratio test. Now you might say, yeah, but what about this guy? It's an alternating series. True, it is, and so you could try to do the alternating series test, which is not easy at all. To calculate the limit of this function is very difficult, this expression, because there is no function x factorial, there's only a function n factorial. So a lot of the techniques that we use for solving limits don't work. And so it's really something, when factorials, you don't really want to calculate the limit of such an expression. Not unless you use a ratio test. You say, why is that? Why is that makes it better? Because you'll see, right? And we have seen this now. Okay, so let me write up what we need to do. We have to calculate the limit for n going to infinity, absolute values. So these everyone will write them and then say what to do with them, right? So let's write everything first. Not forget a single thing here. I'm going to write the same on top, but taking into account that I have to replace n by n plus 1. So, okay, I'm going to do this. This is my n, and then I have an n factorial here, squared, and I have a 3 to the power n divided by 2n factorial. And now all these little n's have to become n plus 1. So this is n plus 1, n plus 1, and because I don't want the factorial sign to just apply to 1, I have to put parentheses. N plus 1, parentheses are not really necessary, here they're definitely also necessary. Okay? Good. Now, first of all, these absolute value signs. What they mean is we don't care about the sign. And what is causing these things perhaps to be negative is these powers here, right? So you could try to simplify the powers, but forget about it. It doesn't matter. It's minus 1 or plus 1, whatever it is, and we take absolute values so they disappear. So the absolute values make these two guys just completely disappear. But because it's power minus 1, right? Not these guys, right? These are different powers, so those we have to look at. Okay, so, all right, so what we get is limit n going to infinity. All right, so what we have on top, we have this n plus 1 factorial squared, with this 3 to the power n plus 1, and also this fellow here in the bottom will come down. That will come up. And then what is left is 2n plus 1 factorial, I should put that there, right? And then an n factorial squared and a 3 to the power n. Good. Now the n factorial squared is perhaps a little bit throwing you off, but not so much. Let me just, you could write it as n plus 1 factorial times n1 plus factorial. Makes it a little bit easier, but let's just keep what we have. What is the deal with the factorials? Well, let's look at this one first, right? We have an n plus 1 on top, and in the bottom, the top one is the biggest one, and it's always with the biggest one that we're going to write in terms of the smaller one. So we want to write 1 plus 1, n plus 1 factorial in terms of n factorial. Meaning, what more factors do I have to include to get from n factorial to n plus 1 factorial? And the answer is, well, only 1. Because you have to go from n to n plus 1, and that's you're there in one step. So that's it. Now, why is it different here at this guy here? So, sorry, I actually forgot to write one of my parentheses. We should work this out, right? So 2 times n plus 1 is actually really, sorry, I'm going to replace this here already, to work this out, is really 2n plus 2, right? So the biggest one is in the bottom now. So this one, 2n plus 2 factorial, I have to write in terms of the top one, which is 2n factorial. So this means I have to go from how much more do I have to do to calculate this as opposed to calculating this. Well, I have to go instead to 2n to 2n plus 2. And I can only go by steps of 1. So from 2n I can go to 2n plus 1. Am I there? No, you're not there. So do another step, 2n plus 2. Okay? And now I'm there. So now I can write this everything. I'm gonna do just a lot of things, so I don't want to squeeze them. The n plus 1 factorial is n factorial times n plus 1 squared. So I'm squaring each separately, that's fine. Then the power is 3 here. The highest power is on top, so we have a 3 here. So that's a 3. And then we have the 2n factorial here. In the bottom, we have the n factorial squared. The 3n is gone. And then we have, we use this expression now, 2n factorial times 2n plus 1 times 2n plus 2. And then we can simplify. We have an n factorial squared, those goes, and the 2n factorial goes with 2n factorial. Okay, and in fact, if you see here, we can also fact this is actually 2 times n plus 1, right? I'm going to write it this way, so I can actually cancel one of them and have a 2 in the bottom left. So let's see where we are. The limit n going to infinity. On top I have a 3 and an n plus 1. In the bottom I have this 2, and then also a 2n plus 1. Okay, and this is a rational function, which we always do this. We can do L'Hopital here, but okay, I'm going to do, my favorite is always dividing by the highest degree term, which is n everywhere. And then I'm left with, oh, okay, let's deal with that. 3 limit, we go into infinity, 3, 1 plus 1 over n. Notice that I don't expand the 3 here, there's no need for it, so I leave the 3 and the 2 outside here. And then here we have 2 plus 1 over n. And those 1 over n's go to 0 when I plug in infinity, so the final answer here is 3 and bottom 2 times 2, so 3/4. Now, luckily, that's still less than 1, so we have convergent. Okay? So here, both in these cases were convergent. But you could have also, think about it. If instead of 3 to the power n, I would have had 5 to the power n, what would have changed? Everything would have been the same, except instead of this 3 here, I would now have a 5, right? So this would have been 5/4. And therefore it would be bigger than 1. So you see, it's very subtle, these things. Sometimes it might converge, it might not converge. You cannot really tell, especially with these kind of factorial things, what happens here. Okay, so these are 2 problems that kind of will cover the next quiz. And so when we talk about more general, when doing series in more general, I'll do another review for that.